So I just want to do a quick intro here. First of all, I'm Joe DuPont. I work with Mantech, been with Mantech for about 3 years. Some of you in the audience may know me as the former PM for electronic warfare, which I did from 2012 to 2015. So we found it a little bit fitting that I actually do this introduction because actually my heart has never left electronic warfare. Really? That better? Okay. You got to stand in front of the mic. All right, so I just want to take a minute to introduce Colonel Holland here. And so he has been the ACM for electronic warfare since 2015. Now, what's interesting about Colonel Holland is he is an infantry officer, which obviously he was too smart to be an infantry officer because he's been all over the map. He has 2 master's degrees. He ended up doing Functional Area 24 for a little while, and now he is actually with the cyber branch. And without further ado, Colonel Holland.
Joe, thanks a lot. I think it's either glass half full or half empty. He said maybe too smart. Probably the reality is I just got fired a few times. But good afternoon. It's great to be here at TechNet, and I'm honored and grateful for the opportunity to talk to so many of you about Army electronic warfare. My goal over the next 30 minutes is really to answer the question, how can industry help us field future Army electronic warfare capabilities? The reality is that we're still building the EW force. We have EW platoons in the MI companies at the Brigade Combat Team, but the EW companies in the Intel EW battalions at Division and Corps are still over the horizon. We have I would argue that we have 2 risks kind of confronting Army EW. The first is that we're not on time as an Army to deliver EW capabilities to the soldiers in these new units. A few years ago, the joke was that EW didn't stand for electronic warfare, but rather for extra worker, someone who's highly trained, has a top secret security clearance, but lacks the equipment to train and fight with. So they end up working in the operations shop, the intel shop, any other shop, wherever the commander needs an extra body. Well, we're still on the clock to figure this problem out, to make sure that out there in the force at the pointy end of the spear, that EW really does mean electronic warfare. One of the first things that one of Joe's successors, Colonel Kevin Finch, told me, many of you know Colonel Finch, he told me a year ago was, Holland, I'm not building EW capabilities in my basement. We need to keep industry informed so that they can build these capabilities. So this goal of informing industry, that's my purpose today, and helping with this second risk that I talked about. The second risk is that the reality actually is that the Army's not going to be able to afford to buy everything that our EW forces need. Our challenge, and what I want to focus on today, is how to dial in these requirements and the technical solutions so that the hard Army senior leader decisions that are forthcoming, really these funding decisions, are informed by accurate requirements and the resultant investment decisions to equip our EW platoons to detect, identify, locate, and affect targets during large-scale combat operations. This is a problem, in my opinion, defined by technology, range, altitude, target sets, weight, frequency, and other technical variables. We need your help, industry's help, to identify not only what's possible, but what technical approaches most effectively and efficiently enable electronic warfare and information advantage on tomorrow's MDO battlefield. So I want to focus on this slide. This slide is our operational view, and it shows the capabilities that AFCEA is working on, that we are working on. And I have several of my team here, the real subject matter experts, and we're available after this for your questions. But over the next 10 minutes or so, I really want to focus in 3 areas. I want to focus on EWPMT, I want to focus on TLIS EAB, and I want to focus on our high altitude system called Helios. The other systems, love to talk to you about it. I actually asked for 90 minutes. They only gave me 30, so I'm just going to focus on these, on the 3, EWPMT, TLIS EAB, and Helios. Look forward to taking your questions on the other capabilities after the presentation. So let's jump into it. EWPMT. EWPMT is a C2 software at the center of the Army's integrated EW portfolio. I would argue EWPMT does 3 things. First, it enables EW planning for future operations, RF propagation, modeling and simulation, line of sight determination based on the terrain. Number 2, EW current operations battle management, receiving and displaying the common operational picture. What exists in the spectrum. Number 3, and what I really need your help on, is unmanned system control, including over-the-air reprogramming. For example, MFU. EWPMT developmental test occurred in May, kind of locking us into Inc. 1, Increment 1, version 1.4, also known as version 1.4. That version, Inc. 1, is at initial operational test and evaluation at Fort Carson right now. I'm going out there next week. That's the background. So we kind of have EWPMT Inc. 1 kind of baked in. Raytheon is the prime. What I really need your help with is the next version of EWPMT requirements. And I want to focus on 3 of them. First, the techniques arsenal. Today, EWPMT enables mission data file upload to the EW sensors and shooters that you see in this diagram while in flight or while on the move using the Tactical Common Data Link. That's great, but EWPMT Inc. 1 expects that these mission data files, electronic countermeasures, will be local on the hard drive of EWPMT. This places the burden on every EWO and SEMA chief out there to kind of monitor and groom his or her own local library. I would equate this to like the iTunes model, where it's up to the user to manage their own database. Instead, what we want your help is to create a centralized electronic countermeasure database back end to EWPMT. We're affectionately calling this the techniques arsenal that provides a central database of all these existing mission data files and electronic countermeasures. I would equate this new version, this new requirement, to the Apple Music or the Spotify model, which provides visibility, awareness, distribution, and version control to the EWO. I would be remiss if I didn't quickly pause here and talk about standardized countermeasures. This is very closely related to the techniques arsenal. We want to uncouple countermeasures from the sensor or the shooter. CMOS is helping us, but only gets us so far. I'm really talking about countermeasures for special purpose electronic attack. We want to enable the sensor or the shooter that's in the right position on the battlefield, with line of sight, with the right antenna, adequate power, taskable via EWPMT, any sensor, any shooter. We have the countermeasure, we put it on the system, we conduct EA. We can't do that today. We're locked. We have countermeasures for MFU Air, we have countermeasures for BCT. We want to move to the future. We want standardized countermeasures distinct from the sensor. Okay, so that's requirement number 1. Requirement number 2 is, General Stanton and General Morrison talked about this, information advantage enabling decision dominance. We're learning a lot from the Navy's investments in CWIP about the problem of emitter density and managing clutter in EWPMT on the battlefield of the future. We need EWPMT, we need cognitive science-based user interface enhancements to EWPMT Inc. 1. This helps the EWO sense, understand, decide, act, assess in the electromagnetic spectrum at combat speed. This helps the EWO support the commander's decision requirements. And these cognitive science-based user interface enhancements will allow the EWO, the SEMA chief, to manage the volume and variety and veracity of data on the MDO battlefield. Sensor data, target data, countermeasure data. And then third, we're looking for industry's help in using artificial intelligence to assist the EWO in assessing the kill chain. We want to connect the dock temp, the sit temp, order of battle, the electronic order of battle, targets, target elements, aim points, non-lethal reference points. We want to do this automatically in the background and help the EWO make decisions about how to produce the effect that the commander wants. We want to integrate that technology into EWPMT. All right, part two, probably the elephant in the room. Let's talk TLIS EAB. But to talk TLIS EAB, we have to zoom out and examine terrestrial air system echelons above brigade. In order to talk TLIS EAB, we have to zoom out and examine the dilemma of long-range precision fires programs that are soon going to field to division, corps, and MDTF commanders and provide them the ability to outrange their current sensors. Consider, for example, the precision strike munition, which according to Lockheed Martin's website, shoots out to 500 kilometers. Another example, again according to Lockheed's website, is the Guided Multiple Launch Rocket System Extended Range, which shoots out to 150 kilometers in all weather conditions. If you Google Extended Range Cannon Artillery, you'll find an Army.mil article from March 2021 that states, quote, in November 18, an early IRCA variant, the XM-1299 howitzer fired projectiles out to 72 kilometers at Yuma Proving Grounds, the farthest reaching shots ever made by U.S. Army howitzers, and more than double the reach of currently fielded artillery systems, end quote. These distances are illustrative of the problem that commanders will soon be able to shoot farther than they can see. Manned by the Intel EW Battalion and MDEP, SIGINT, and EW soldiers, TLIS EAB is an integrated SIGINT EW cyber capability that provides target detection, identification, geolocation, and effects, non-kinetic effects against targets to support division, corps, and MDTF operations. TLIS EAB is part of the solution to this commanders can shoot farther than they can see problem. TLIS EAB addresses two main gaps. LISCO gap 1, deep sensing, and LISCO gap number 2, lack of EW at echelons above brigade. So how can you help? TLIS EAB is really about how to sense and deliver effects farther using a terrestrial system. What do we need from you? First, the system needs to be mobile. It needs to be based around a manned wheeled prime mover, like an LMTV or an FMTV. In a degraded, intermittent, and latent battlefield, the system needs to be able to provide organic target identification and geolocation, although not necessarily with just one system. Think the systems that are fielded at an echelon. So the TLIS EABs working together at division need to be able to organically ID and geolocate targets. A few different theories we have on how to do this. Many of these ideas enabled by significant investments across the DoD and the Army, and possibly government-furnished equipment to industry. We're looking very closely at tethered apertures. So a tethered antenna, either on a balloon or a UAV, tethered UAV, that gains line of sight by putting an antenna at altitude. Another idea we have is an untethered but dedicated vertical takeoff and landing UAS, a follow-the-leader UAS that's dedicated to the vehicle on the ground. Probably a large Group 2 UAS or a small Group 3 UAS, maybe with modular, hot swappable payloads customizable to meet mission needs. We're looking for the smallest possible payloads to make this system portable on the battlefield. We're also really interested in the feasibility of electronic attack from a tethered and rapidly deployable drone or aerostat, or a tethered or an untethered UAS. And we think the challenge here is creating enough swap for effective radiated power at altitude. We think the trade space is between rapid launch and recovery and payload weight. And we're willing to customize payloads in order to get the swap down. We're also very interested in beyond line of sight, over the horizon, passive, high accuracy detection. It's not applicable to all targets, but definitely relevant to adversary radars. We're also looking at forward positioning a containerized system during competition and then remotely operating it from sanctuary or from a forward base. Maybe think palletized loading system, PLS, easily zeroed out, anti-tamper, able to zero out if necessary. We're also prioritizing ground-to-air electronic attacks since we'll have more favorable line of sight looking up from the ground into the air to disrupt adversary aerial ISR. And we're very interested in small, active electronically steered arrays for high gain and multiple simultaneous engagements. Let's talk a few things that are not a great match for TLIS EAB that ideas we've heard from industry. Penetrating robot vehicles that kind of drive forward in the battlefield. We think that's not a good fit. Cannon or rocket delivered sensors or effectors, AKA unattended ground sensors. Probably not a good fit for TLIS EAB. And dual purpose electronic attack, kinetic loitering munitions like the Harap or Harpy. Let me be clear that those technologies are very interested and we want to talk to industry, but probably, hopefully this week during TechNet, but probably not a good fit for TLIS EAB. If you're working on something like that, let us know. We want to talk to you this week, but again, not a great match for TLIS EAB. Finally, in I think I have a couple minutes left, let's talk high altitude. Helios, the high altitude, extended range, long endurance, intelligence observation system. This is a SIGINT, GEOINT, EW cyber payload for a high altitude, stratospheric, penetrating platform, probably a solar glider or a high altitude balloon. I should note that the proponent for the platform itself, for the balloon or solar glider, is ACM Space and High Altitude at SMD Center of Excellence. Little background, Helios is part of the multi-domain sensor system, and the requirement is currently routing through Army Futures Command. We expect that the abbreviated capability development document should push out to worldwide staffing in the next approximately 45 days. Colonel Will Adams, my counterpart at Fort Huachuca, the Army Capability Manager for Intel Sensors, is the overall lead. The campaign of learning for Helios is underway with the Cold Star and Tripwire joint capability test and demonstrations. We're looking to simulate in Joint Warfighting Assessment 21, live experimentation in Project Convergence 21, and a tech demonstrator in INDOPACOM in FY22. For Helios, we're looking for a SIGINT, GEOINT, EW cyber payload that operates at 60,000 plus feet, low cost because we think the whole system is attritable, capable of operating in low temperatures, and requires low swap. Some interesting concept and technologies that we're tracking include coherent distributed electromagnetic attacks, so multiple low power transmitters, effectors on different balloons or gliders that are very precisely coordinated in time and phase to deliver additive jammed a signal on a single target. Gimbaled high gain beamformed electromagnetic attack, hyperspectral ultra-sensitive antenna technology. We're also interested in exploring, like TLIS EAB, whether we can significantly reduce swap with modular payloads tailored to specific targets. Military comms, firefighting radars, target acquisition, target tracking radars. Essentially, we want to trade specialization for weight savings. The idea is blanketing the deep area with low-cost attritable sensors to enable deep sensing and deep effects. We want to start with essentially the balloon right over the target, so think 18-kilometer nadir line of sight straight down, and then progress from there. We understand as we move the sensor, that the platform and the sensor farther away, the swap will go up, swap challenges increase. So essentially our question is, can we get the payload light enough to fly on this penetrating high altitude, attritable platform, get close enough to place our effects on our target, likely with a special purpose electronic attack or RF-enabled cyber. So I think I'm out of time. And I'm happy to take any questions and look forward to engaging with you and your team later today and later this week. Thank you very much. Yes, sir.
I know y'all are in the discussion right now with the acquisition side as well in regards to TLS EAB, and everybody's been waiting for the draft request for white paper, and you know about when that could be expected now, or has that been delayed further out now?
I don't want to speak for the new PM EWPMT, Ken Strayer. We have a panel. Hope you'll join us on the panel on Thursday. Fourth quarter. I'll tell you, fourth quarter is the very soon. We're running out of daylight in fourth quarter. So next 45 days, the request for white papers should hit the streets. Good question. Thank you. Anything else? All right. Thank you very much.
Don't forget to scan your badges, please, back here at the back door. Don't forget, scan your badges so you receive credit right here by the back door.